Luigi Galvani was an Italian scientist. He was an anatomy professor. Every year, professors need to publish one publication, one paper. So he was working on acoustics, and one of the guys who were working with him stole his research, whatever that thing is, and then he ended up with no research for his job, and he was going to be fired. So he assembled a group of students, and they say, okay, let's work with electricity, and it was a big thing at that time, 1791. And they were playing with capacitors and inductors. He's an anatomy professor, right? So he was dissecting frogs for a lecture, and one of the dissected frogs was placed on a table, and one of the students accidentally touched the nerve of that frog with an electrode connected to a battery. And immediately the muscle twitched, right, the frog. And this was the first time in history we realized that electricity affects nerves, and that resulted in contracting muscles. That was 1791. Galvani didn't know what was happening, and his hypothesis was that there was a fluid that is passing through the muscles and the nerves that is making it do its job in contraction. But no one knew about electricity before. And then he started creating more and more experiments about the frogs and nerves and electricity. And from that time on, we have the biopotentials, and the electrophysiology became a topic in science. So Galvani attributed bioelectricity to a life force. So we have something called vitalism versus mechanism. So scientists, we like to know how things work. Vitalism, people will say, oh, there is a magic or some sort of superpower acting on things. So he was a believer of vitalism. Then Alessandro Volta suggested that the effect was only due to the similar metals that was on were in the table and the electrodes, and there was nothing into it. We don't have any potential electrical activity. Then Carlo broke the deadlock and confirmed Galvani's experiment that switching was a result of electrical current. He proved that the electrical current propagated through nerves. They were calling it current, electrical current, but actually it was ions, it wasn't electrons. That's why they were unable to detect it, because it was ions and channels and all other things that we discussed before. Mathieu also showed that the action potential precedes contraction of the muscle. He also showed that action potential starts first, they can detect it, and then the muscle contraction happens. And that is another important finding. And then we have electrophysiology discipline, and the basic notion to design certain, we start using biopotential and electrophysiology to design equipment. And that was the story behind electricity and medicine and how they were related to each other.